Let's graph systems of inequalities. This is very similar to an earlier video where we graphed an inequality in two variables, but now we're going to do it with systems. And the most important thing to remember here is that when you're using a line that has a greater than or a less than, that line is going to be dashed. However, if it's a less than or equal or a greater than or equal, it's going to be solid. And just like before, we're going to get our graph and we're going to shade on one side or we'll shade on the other, depending on whether that makes it true or not. And by default, all systems of inequalities are AND problems, meaning we only shade where both lines are shading, or if there's three lines where three lines are shading, or however many lines there are. We can only shade the region that makes every piece true. So, for example, let's suppose that we have the system x plus 2y is less than or equal to 8, and 2x minus 3y is less than or equal to 9. Now this first line that we're going to do is pretty easy to use intercepts on because the x and the 8 divide evenly and the 2 and the 8 divide evenly. So x, when y is 0, x is 8. So 1, 2, 3, 4, 5, 6, 7, 8. And when x is 0, y is 4. So 1, 2, 3, 4. And we get a solid line through those 2 points, and we graphed using intercepts. Now, if this were my only line, and I were to plug in the point 0, 0, 0 plus 2 times 0 is less than or 8, 0 plus 0, 0 is less than 8, so that's true. So he wants to shade this way, and if he were the only line, that's where he'd shade. However, we also have to worry about our second line. And this one's not quite as nice. Notice that the 2 and the 9 don't divide evenly. So let's solve this one instead. We're going to go minus 3y equals minus 2x plus 9. Let's subtract 2x. Divide by a minus 3. And y equals 2/3 x minus 3. So our line starts at minus 3 and goes up 2 over 3, up 2 over 3, up 2 over 3, and we get another nice solid line through here. And when we plug 0, 0 into this line, we get 2 times 0 minus 3 times 0 is less than or equal to 9. 0 minus 0 is 0. 0 is less than 9, so he wants to shade this way. So we have a total of 1, 2, 3, 4 regions to shade, but the only one that they both want to shade is right here, the region containing the point 0, 0, since that is true for both of them. So I just shade it in, and I get my answer. Well, let's look at another one. Suppose we have the system 2x plus y is greater than 2, and 2x plus y is less than minus 2. And again, we'll bring our graph over. Well, in this case, they both graph very nicely by intercepts. 2 goes when y is 0, x is 1, and when x is 0, y is 2. And so I get this nice line, and this one is dashed, so we make it a dashed line. And he wants to shade 2 times 0 plus 0 is bigger than 2. 0 is not bigger than 2, so he wants to shade away from 0, 0. Our other one's similar, but instead of being at positive 1, it's at negative 1. And instead of being at positive 2, it's at negative 2. And so we get our shaded line like this. And again, when we plug in 2 times 0 plus 0, that's 0 is not less than minus 2. Since that's false, these were both false. They don't shade towards 0, 0, they shade away from it. And since the blue line is shading up and the green line is shading down, there's nowhere they both want to shade. So this is our answer. We have no solution on this one. One final example. Suppose we have x plus y is less than or equal to 3. 2x plus y is less than or equal to 4. X is greater than or equal to 0, and y is greater than or equal to 0. So we're going to drag this line, our graph in. And remember, it's where all 4 of these are true that gets shaded. So we're going to start with 1, 2, 3, and 4. 1 is a great graph for using intercepts because a 1 and a 1 go into 3. So I get a point at 3, 0 and 0, 3. And it's a solid line going through there. And since 0 plus 0 is less than or equal to 3, he wants to shade here. The second line is almost as easy, but still not too bad. When y is 0, x is 2. When x is 0, y is 4. And we get a line that goes through our points like that. And again, 0 is less than or equal to 4. So he wants to shade this way. And we'd shade this big region right here if we could. But we've got line 3. X is greater than or equal to 0 is straight down here, shading this way. And y is greater than or equal to 0 is a horizontal line that wants to shade up. And the only region that all 4 lines want to graph is this one right here. And that is how we graph systems of inequalities.